Hey everyone, welcome to the Pre-Algebra 8.4 video where today we're talking about the slope of a line. So what's a slope? Well, slope in general is the rise over the run. Okay, so we always talk about slope in terms of a fraction of rise over run. Now, rise doesn't just mean up, it actually can mean down, and run could mean to the left or to the right. So if we look at these two lines, we see that, this black one, to get from one point to the next, you're going to have to rise upward and run to the right. But this orange one, to get from this point to this point, you have to rise downward and then run to the right. Or you could go from this point to this point by rising up and then running to the left. And same thing over here. You could rise downward, which sounds kind of weird, right? Rise down, but we're like sinking down and then running to the left. So we're going to kind of explore all the nuances of that. So slope can be a couple of different things. Slope could be positive, and a line with positive slope would look like this. And all that means is that from left to right, this line goes up. Okay, he travels upward from left to right. Now, a line could have negative slope if from left to right, that line moved downwards. Okay, now, a line could also have zero slope, and a line with zero slope, well, I guess it would be like that, but would look exactly like that. So what do we see? That is a perfectly horizontal line. Okay, it has zero slope. Now, the way I like to remember zero slope, and we're going to try and keep that different from no slope, which we'll get to next, is two different things, is that, if you imagine like angles, right, we would say, okay, that's like approximately a 90-degree angle, and this would be like a 45-degree angle, and then this would be like a 20-degree angle, right? And so what we're seeing is as that comes flatter and flatter and flatter, becomes flatter and flatter and flatter, it's eventually going to flatten out, in a flat line like that, if it were, I guess, really, it would be like taking this portion of the line and moving him over and over and totally flattening him so that it really resembles two different rays on top of each other. That would be 0 degrees, right? So that's how I like to remember zero slope, is that it's flat. And it would be like an angle 0. Now, non-existent slope is really more often called no slope. So what does a line with no slope look like? Well, we've talked about positive slope, negative slope, zero slope. So really our only other option would be a line that looks like this. Okay, like that. It could be there or there or there or there, anywhere. But what we notice is that it's perfectly vertical. Now the way I like to think about no slope, and remember that, is that picture, there's a little person and they're up here on a cliff and the wind comes and knocks them off, right? And oh no, so right as they're falling, what are they screaming as they fall? They're not screaming 0, they're screaming no, right? So that's how I like to remember no slope. Perfectly vertical line, yes. Tacky, yes. Corny, but it works, so I don't care. So now what we're going to do is we're going to work on calculating the slope of a line if we're given 2 points. Now these points are not on a graph, so what do we do if we're supposed to calculate the slope between those 2 points? I can't even see those points on a graph. Well, we can do it by a little formula that goes like this. M equals y2 minus y1 over x2 minus x1. Now, what does that mean? Well, we see y and x, and I see points, right? Well, I know that points are made up of x and y coordinates, right? And if I'm calculating the slope of a line that runs through 2 points, that means I have an x here and an x there and a y there and a y there. So basically I have 2 x's and 2 y's. So what I do is I go to my first point, and I'm going to say, okay, 3 is the x1 coordinate and negative 6 is the y1 coordinate. 7 is the x2 coordinate and negative 4 is the y2 coordinate. Right? Basically the first x and the first y and the second x and the second y. So then what do I do with that? Well, I'm going to plug those things into my formula. M is going to stand for the slope, right? So we're going to have the slope equaling, well, what's our y2? Well, it's going to be negative 4. Minus our y1, which is over here, and he is negative 6. So we have a double negative there. That's going to happen a lot, so you got to be careful. Over x2 minus x1. Oops. So x2 minus x1. Well, x2 would be 7 minus our x1 was 3. And so what we have now is a simple equation that we can solve, and that's m equals negative 4 minus negative 6. That's like saying negative 4 plus 6, which would be 2, over 7 minus 3, which is 4. Now, we always do talk about slope in terms of a fraction, but we can always simplify fractions. In this case, we would simplify 2/4 to 1/2, and we would say the slope of the line that runs through both 3 negative 6 and 7 negative 4 would be 1/2. Alright, so why don't you pause the video and I want you to try this one using our m equals y2 minus y1 over x2 minus x1 formula. Okay, calculate the slope of the line that runs through those 2 points. Play the video when you're done. We'll see how you do. Alright, so if I'm plugging into my formula, the slope is going to equal my y2. Well, which point is the second point? This one. And what's the y coordinate? It's a 1. Minus y2. Well, this is the, minus y1. This is my first point, and what's the y coordinate? It's a 5. Divide that by x2. So what's the x coordinate of my second point? It's the 4. Minus the x coordinate of my first point, which is a 1. And now I can solve by doing 1 minus 5, which gets me negative 4, over 4 minus 1, which is 3. Now, this is a fraction. We like fractions when it comes to slope, but we have to simplify if we can. However, here, can we simplify? Negative 4/3? No, actually we can't, so we would be done. Now, if I said, what's the type of the slope, what would you tell me? Hopefully you would say, you know, it's negative. And why is it negative slope? Well, guess what? It's a negative 4 over 3. That's a negative fraction. It's negative 4/3. So another way you could also write that is a negative 4/3 with a negative out in front of the middle. The only thing you don't really want to do is leave the negative with the denominator. But both of those are great, and that is the type. All right, so do the same thing again. I want you to calculate the slope that runs between the line that runs between those 2 points, and then play when you're done. All right, so as I set up, my m equals y2 minus y1 over x2 minus x1. Again, m stands for the slope. Y2, so that's going to be a negative 1. Minus y1, which is 3. All of that is over x2, which is 6, minus x1, which is, again, a 6. So, in solving, we would say, well, all right, negative 1 minus 3, that's a negative 4, over 6 minus 6 is 0. Now, again, we like fractions, so can we simplify this? And I start to look at that, and I go, wait, hold on. If I had the slope of 1/2, that would technically divide to 0.5, right? However, if you take in your calculator negative 4 divided by 0, what are you going to get? You're going to get an error, okay? It's going to say error or div0 error, okay? And what does that mean? Well, it means you can't divide by 0. So, what is our slope here? Is it 0? No, because negative 4 divided by 0 is not 0. It's an error. You can't do it, actually. So what it means is that there is no numerical slope of a line that connects these two. And in fact, if I just kind of sketch these points real quick, let's think about what they look like. If I were to sketch 6, 3, I'd go over 1, 2, 3, 4, 5, 6, and then up 1, 2, 3, and there would be 6, 3. I'll do that in orange, I guess. Okay, now if I wanted to sketch 6, negative 1, I'd go over 1, 2, 3, 4, 5, 6, down 1, and there would be that point. And if I had a line that connected those 2 points, well, wouldn't it look like this? Yeah, and what do we see about that line? Well, that's a vertical line. Vertical lines don't have a numerical slope, but they do have a type of slope, okay? So what is the type of slope? The type of slope is no slope. So you don't actually give a number, but you do give a type, and that is no slope. All right, so another one. Go ahead and do the same thing. Calculate the slope there, and tell me the type of slope, and then see how you do. All right, so if I'm calculating the slope, y2 minus y1 over x2 minus x1, so that would translate to 1 minus 1 minus 1 over 2 minus negative 16. So what does 1 minus 1 end up getting me? Scratch that up. That's a 0. 2 minus negative 16 is like 2 plus 16, which is 18. Now, 0 over 18, well, what does that mean? Well, technically that is something you can simplify, and it would actually end up equaling just what? Well, it would be 0. So 0 is the numerical slope of the line that connects those 2 points, right? But also, what's the type? The numerical slope is 0, but the type of slope is the word 0. So it's a 0 slope line, and the type is 0. Now let's think about that. Does that make sense? Well, if I graphed those 2 points, right, negative 16, 1 would be over 1, 2, 3, 4, 5, 6, right? But negative 16, and then up to 1, and he'd be right there. There's that point. And then if I graph 2, 1, I'd go over 2, and then up 1, and he would be right there. So the line that connects those two, think about it, it's going to be what? Well, it's going to be, and that's not perfect, but it's a horizontal line. And horizontal lines have a numerical slope of 0 and the type of slope of 0 as well. So slope is so important. As far as algebraic topics go, it's one of the most important, if not the most important. It's also a big jumping off point where we can go to explore so many other topics. But we have to have slope mastered first. And one of the reasons is that slope is so applicable to so many areas of everyday life, right? So we're going to talk about speed here just for a sec. Slope is often used to represent speed. So what I did is I drew a graph here. And let's say this represents maybe like you're out, I don't know, in a kayak or something like that, right? Okay, and you're maybe going down kayaking down a river. You're going relatively fast for a kayak, not super crazy fast or anything like that, but pretty fast. And what happened here is I mapped or graphed your distance as a function of your speed. Now, distance as a function of speed. It sounds kind of complex, but really it's not, because look at this line. Okay, so let's explore this line. As this line continues, and first of all, what kind of slope does it have? Well, it rises from left to right, so it's positive slope. As this line continues, well, distance also increases as time increases, right? So as this line kind of grows, both distance and time increase. And that makes sense, right? Because like if you get in a kayak and start to paddle, your 1, distance is increasing, and 2, time is going on, right? Like time passes when you get in a kayak. When you get in a kayak, it's not magic and time stops, okay? So let's think about a couple points on this line right there. Okay, what does that point right there mean? Well, that point means the coordinates are 1, 20, all right? However, let's think about this line in terms of slope, which we know is rise over run. Okay, so my rise to get from, well, my starting point right there of 0, 0, right? If I'm just sitting in the kayak, I haven't started to kayak, so time hasn't started going on, and I haven't covered any distance, so I'm at 0, 0. To get from here to here, what happens? Well, again, this point right there is the coordinates 0, 0. So this is my first point. This is my second point. Let's calculate the slope that connects those 2 points. Well, remember slope equals y2 minus y1 over x2 minus x1. So my y2 is 20 minus my y1 of 0 over x2 of 1 minus x1 of 0. So what does that end up equaling? Well, you end up getting 20 minus 0, which is 20, over 1 minus 0, which is 1. So 20 over 1 is our slope. Now, let's consider what 20 over 1 means. So remember, 20 is rise, okay, and our 1 would be our run. Rise means y, and run means x. So it means 20 rises, which in this case are miles, over 1 x, or times, which in this case is hours. Now, what do we have here? Well, we have a ratio, and we've talked about this for a long time now, and the ratio is 20 miles to 1 hour, otherwise known as what? 20 miles per hour. Okay, so let's consider something. If you're traveling in a kayak at 20 miles per hour, how many miles will you go in 2 hours? Well, hopefully you would understand 40. So let's think about it. When I'm at 2 hours down here, where does my line hit? Well, right there. And right there at 2 hours is 40 miles, or 40 miles per 2 hours, right? 40 miles per 2 hours, which would simplify back down to our original slope of 20 miles per 1 hour. So there's your kind of quick crash course on how slope is used, and we're going to talk so much more about that. But for right now, that is all I have for you guys. Thanks for sticking with it. I'll see you in class.